Okay, welcome to a review on parallel lines. We'll be basically reviewing the theorems and postulates involving parallel lines. Essential questions: how to use a parallel postulate and how to use an auxiliary line. So here we've got two lines and a transversal, and I've got 8 numbered angles. The transversal is line T. It crosses both lines at 2 distinct points. My corresponding angles, which I abbreviate with CA, are 1 and 5. They're both in the upper left, same relative location or corresponding location. 2 and 6, upper right. 3 and 7, lower left. And 4 and 8. And you notice just being corresponding angles has nothing to do with whether the lines are parallel or not. It's just the location of the angles in relation to the two lines and the transversal. My alternate interior angles are 3 and 6, alternating meaning on opposite sides of the transversal, interior meaning between the lines. And the other pair is 4 and 5. Alternate exterior means outside the pair of lines and alternating. So one pair is 1 and 8, and the other pair is 2 and 7. Then I have same side interior, same side of the transversal, between the pair of lines. So 3 and 5 and 4 and 6. I can also call these consecutive interior angles. Other thing I have is same side exterior. You don't see this reference too often, but same side and outside the pair of lines. So 1 and 7 is one pair, 2 and 8 are the other pair. Now, when I have parallel lines and they're cut by a transversal, certain things are going to be true. And these are that my corresponding angles are congruent. And when I use this in a proof, as my reason, I'll put parallel implies corresponding angles, or CA, for corresponding angles, congruent. I don't want to say corresponding angles postulate, because in some books, this is actually the corresponding angles postulate converse. So by referencing it this way, everybody knows exactly what we're talking about. The second one is when I have parallel lines, my alternate interior angles are going to be congruent, and I write that as parallel implies alternate interior angles congruent. Third one, if my alternate exterior angles are, when I have parallel lines, alternate exterior angles will be congruent, and I write that as parallel implies alternate exterior angles congruent. And then same side interior or consecutive interior. So when I have parallel lines, my same side interior angles are going to be supplementary, and I write that as parallel implies same side interior supplementary. Now, something new here is a parallel postulate. And the parallel postulate states that through a point not on a line, there is one and only one line parallel to the given line. So if I have line M and point P here, there's only one line that goes through P that will be parallel to line M. And here I've put in line N, and there will only exist one line that fulfills this. The other thing we have is auxiliary lines, and they're added to a figure to make a calculation or proof easier. And so we will give an example of using an auxiliary line here. This is in what's called a crook problem, and I want to find the value of x that will make line K parallel to line L. So I've got I'm going to put this auxiliary line right here, and using the parallel postulate, I'm going to mark that these two lines are parallel. And the parallel postulate says that that line exists, and it's an auxiliary line in this problem. So now I have a transversal here, and I've got a pair of parallel lines. Since this angle is 120, this corresponding angle here is going to be 120 degrees. Now, these two angles make a linear pair, meaning that this right here is going to be 60. I know the whole angle is 95. So what's left is going to be 95 minus 60 is going to be 35. So this part here is 35 degrees. And then when I look at my alternate interior angles, this angle, well, I want to get L parallel to this. So that means I need this angle and this angle congruent, which makes that 35 degrees. When that's true, these two lines will be parallel. And now by the transitive property of parallel lines, since K is parallel to this line and this line is parallel to L, K is going to be parallel to L. And now that that's 35, I know that these two angles add 180 because they're supplementary by the linear pair postulate. So 180 minus 35 gives me 145 degrees for X. Now, when I want to prove that two lines are parallel, basically the converse of what we were doing earlier, one of the following has to be true. First thing, if corresponding angles are congruent, the lines are parallel. And I'm going to write that as corresponding angles congruent implies parallel. Second reason is if alternate interior angles are congruent, then the lines are parallel. And I write that as alternate interior angles congruent implies parallel. Third reason, if alternate exterior angles are congruent, I'm going to write that as alternate exterior angles congruent implies parallel. Fourth reason, same side interior angles are supplementary, then the lines are parallel. I write that as same side interior supplementary implies parallel. I can also call these consecutive interior, but I don't like to use consecutive interior because it could be confused with corresponding angles. Fifth way is if I'm in a plane and two lines are perpendicular to the same line, then those two lines are going to be parallel. So if I have line A perpendicular to line B perpendicular to line C, then line A is parallel to line C. And then the final way, and this is the transitive property of parallel. If I have two lines parallel to the same line, then those two lines are going to be parallel. So if I have A parallel to B and B parallel to C, that's going to imply that A is parallel to C. Now, these are reasons you'll use in proofs. And the other one where we started with parallel are other reasons you'll use in proofs. So thank you for watching this review.